Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So right now I'm going to show you the overall arithmetic logic unit, also known as ALU design, that we have made in quartus, which integrated the function of multiplexers, full adders, and also register. So here we got the multiplexer, which will select the numbers of A and B, which will go through the arithmetic process of addition or subtraction, which is determined by the ALU operation, this input right here. And then it will store on the register for every positive edge clock produced. So first up, let's look at the initial. This is the circuit diagram for the multiplexer, and then we can represent this as a block and combine it to become a selector, a 4-bit selector number, which have 4 multiplexer here, and it will produce an output of 4-bit, which is equivalent to the number that we have. Of course, our number A and B is 4-bit, right? So, and then we have for the adders, this is the basic, the fundamentals of the full adder. This is all equivalent to one full adder. We have the C in and we have A and B, the 2 digits, and then we represent it as blocks, and we can combine it to become a 4-bit full adder subtractor. So each of this one block here is equivalent to the circuit that I've shown you, the logic gate circuit one. We have the ALU operation, which will determine whether it's subtraction or addition, in which 1 will function as subtractor and 0 is addition. So now let's take a look at our final integrated design here. So we have the multiplexers. So this one is equivalent to the 4 multiplexers, and also this one is equivalent to 4 multiplexer, and this one is equivalent to the full adders, to the 4 full adders that I've shown you, the 4-bit full adder, and this block right here is equivalent to the register. The register, this is for the register circuit. It will store 4-bit input every time the clock is positive edge. So we take a look at the final outcome. So here is the ALU design, the overall ALU design. We have a look at the waveform here. So an example of waveform, we look at the input initially at the first rising clock here. So our selector for B is 0. So our input for B here is going to be B0, which is B000. And our A selector is 0, 1. So it's going to select A1 number, which is 1100. And since our ALU operation is 0, so the arithmetic process will become addition. So if we add 1100 and also 0000, it will produce an output of 1100, of course. So at the positive edge clock here, since the clear is 1, so it's not resetting. So the register will store the input of the 1100 as shown here. So therefore you can see that we've completed the ALU design using the most minimalized logic gates and the most simplified version here, which only consists of blocks. So that's it for this video. Thank you very much.